Hi all, it's me Adithyan from Excel Education Center, your physics faculty. Today we are going to start a new series known as Rapid Focus. In this session, we are going through chapters with the concept and concept-based questions. So, welcome to our new session known as Rapid Focus. Our first chapter is Current Electricity. Okay, so we can go to the chapter. So to the first topic, we are dealing with the electric current. So what is basically electric current? In the first chapter and second chapter are dealing with the electrostatics. Okay, what is meaning by electrostatic? Static means rest, electro means charge. So the first and second chapters are discussing the charge at rest. In this chapter, we are discussing the rate of flow of electric charge. The rate of flow of electric charge. So what is mean by current? Current is the rate of flow of, or we can write it as I is equal to dq by dt. I is equal to dq by dt. What does it mean? Okay, it means by that current is actually the flow of charge. Current is actually the flow of charge. If the charge is at rest, it is known as electrostatics. In the first chapter and second chapter, Coulomb's law, potential, electric field, the electric field lines, these are the topics which are related to electrostatics. In the session, the actually charge is not at rest, the charge is flowing, so it is known as electric current. I is equal to dq by dt. It is one of the most important equation. You have to know the concept and you have to know the equation. I is equal to dq by dt. So steady current is given by the equation I is equal to q by t. What is the difference between these two equations? This equation gives about a current, instantaneous current. This equation gives about a instantaneous current, while this equation gives about the average current or the steady flow of a current. Okay, you know the difference between average and instantaneous. We will discuss it in many cases. So dq by dt gives the instantaneous, while I is equal to q by t gives the average. Okay, I is equal to q by t gives the average. Electric current is you can see it as electric current is actually a scalar quantity. It's a very important point actually. Electric current is actually a scalar quantity. While it have the direction of electric current is the direction of electric current is positive to negative. Okay, that point is actually a bit confusing. What is in it for the confusion? So according to our definition, we know that there is two quantities. One is scalar quantity and another one is a vector quantity. According to our definition, a vector quantity is a quantity having both magnitude and direction. So if a quantity have the magnitude and direction, it's clearly it's a vector quantity. Should be a vector quantity. Here it has a magnitude I is equal to q by t. I is equal to q by t is the magnitude, and the direction is specifically clear that its direction is from positive to negative. It has the magnitude. Does current has magnitude? Yes, it has the magnitude. Does it have a direction? Yes, clearly it has a direction. Where to from? Positive to negative. Still, it is not a vector quantity. Why? Okay, you have to know one more concept here, that a quantity is said to be vector if it obeys the laws of vector addition. That is the point. That's a very important point. Mark the point actually. We have to understand that a quantity is said to be vector if only it obeys the laws of vector addition. We know the triangular law of vector addition, vector A plus vector B, in which the resultant vector will be something like this: R is equal to A plus B. We all know this. It is known as the triangular law of vector addition. Just consider this case: if current is flowing from A, okay, current is flowing through in the conductor A and current is flowing to the conductor B, you will not get any result. You will not get any kind of result in this point. You will not get any kind of result in this point. No, that is not possible. You just take a charge wire, make an angle between the wire. So when a current is flowing through the wire, you will not get shocked by a shock from putting your hand on this specific location. There is no result. Resultant is actually here. There is no result, which says that it has a magnitude. Yes, clearly it has a magnitude. It has the direction. Yes, it has the direction. Still, it do not obey the laws of vector addition. So current cannot be basically a vector quantity. So not the point. Okay, clear. Then there is something you want to know, that I is equal to, just understand concept understand this concept, we know that I is equal to Q by T. I is equal to Q by T. The question is, what is 1 ampere? Okay, what is 1 ampere? It's very easy. 1 ampere is equal to 1 coulomb by 1 second. So 1 ampere is equal to, it is the flow of 1 coulomb of charge. It is basically the flow of 1 coulomb of charge in 1 second. If 1 coulomb of charge is flowing in 1 second, it is said to be 1 ampere of current. So these are the topics you should know about the electric current. It is the rate of flow of electric charge. The instantaneous value is given by, the average value is given by. Electric current is a scalar quantity. It's a SI unit. What is mean by 1 ampere? 1 ampere is mean by 1 coulomb per second. So these are the basic quantities. These are the basic topics you should know about this section. Okay, clear? So we can go to the first question. So it's actually a direct question, nothing to worry. The current flowing through a wire depends on time. Okay, it is given by, the current is given by a second degree, actually I think it's a second degree equation. Yes, it's actually a second degree equation. Something like I is equal to 3t square plus, I is equal to 3t square plus 2t plus 5. Okay, it's already given in the equation. I is equal to 3t square plus 2t plus 5. Okay, then the charge flowing through cross section of the wire in the time, actually the time interval is given. Okay, okay, so just consider this. I'm reading the question. I'm not answering it. I'm just reading the question. Okay, fine. So the time is given below that. Okay, if you have any kind of problem or if you have any kind of doubt, so just ask in the comment section, let me know. So the time is actually t is equal to 0 to 2 seconds. The time is given by 0 to 2 seconds. Okay, so I'm marking the time from t is equal to 0 to 2 seconds. These are the given topics. Okay, fine. Okay, then we have to find the charge. So what is the question actually? The question actually says how much is the charge, if the current is given below, and how much is the charge. So we want to find Q. The question mark is, the real question mark is, you have to find the Q. Okay, so here there are three terms which are I, T and Q. So you have to consider these terms and create an equation. So we know there is an equation, I is equal to dq by dt. So I'm rewriting this equation here. So just consider this. I is equal to dq by dt. Okay, that's it. Fine. So the real question is here to find, not to find the current, the question is to find the charge. So I want to rearrange the equation something like this. dq is equal to I into dt. dq is equal to I into dt. Is that clear? Okay, fine. Then you have to find, okay, what is mean by dq? dq is actually a small amount of charge. Here we want to find the total charge in the time limit 0 to 2 seconds. So how will you convert a small amount of charge into large? You can integrate from the both side. So when you integrate a small charge, it becomes the Q, the total charge. Integral I dt. Q is equal to integral I dt. Okay, so the integration is starting from, here we can go 0 and ending at 2. So it is a given limit that Q is equal to 0 to 2 I dt. So you have to integrate this particular equation, or you have to integrate this particular equation, then you will get the value for charge. That is what the equation says. So we can integrate it. Okay, so we can simply integrate it. I is equal to, sorry. Okay, fine. Okay, Q is equal to integral I dt. So Q is equal to, so you have to integrate it. There are terms. Which are the terms? Okay, so just look into the equations. The terms are actually 3t square 2t plus 5. So 3t square plus, okay, 3t square, and the next term is 2t, and the final term is 5. So I have to integrate, right? Okay, so integral dt over here plus integral dt over here plus integral dt. I just simply applying the equation over the value. Okay, fine, that's it. So Q will be something like this. 3, the integration of, so we can keep the simple mathematics. Okay, that's fine. I think that's fine. Okay, you are used with the integration. I think so. So you are good at, I know that you will be good at the mathematics. So we can simply skipping the small steps. Integrating the t square, you will be end up with the value t cube by 3 plus 2, integrating the t, okay, 2 is actually a constant, okay, removing the term and integrating 2, you will be end up with something like this, t square by 2, and plus 5 is a constant, you are replacing the term, and integral dt will be t. Okay, you can cancel the common terms, then the answer will be q is equal to t cube plus t square plus there's actually 5 is here, 5t, okay. So to the final stage you have to apply the limit. So the limit says that it is from 0 to 2 seconds. So applying the limit, you can see something like this, okay. You can apply 2 cube minus 0 cube plus 2 square minus 0 square plus 5 into 2 minus 5 into 0. You all know that when we multiply a term with a 0, the term will be cancelled, or the negative result will be 0. There is nothing to discuss actually. So 5 into 0 will be 0. 0 cube is actually 0. 0 square is actually 0. Okay, so the terms will be automatically deleted from the equation. So we don't have to worry about that. So just consider 2 cube. What is 2 cube? 2 cube. What is 2 square? What is 5 into 2? Okay, so here we go. The answer will be something like this. 2 cube gives 8. Okay, fine. 2 square gives 4. 5 into 2 gives the 10. So 10 plus 4, 14. 14 plus 8, 22. So the answer should be 22 coulomb. The answer should be something like 22 coulomb. Okay, so it's actually very basic question. There is not something to worry about. Okay, it's actually a very simple one. So the answer will be something like this. Okay, you can see it in the option. I is equal to, okay, 22 coulomb. The answer is 22 coulomb. Option A. Okay, so I think you are all good. So we can go to the next question. In a closed circuit, the question is actually some like similar. So in a closed circuit, the current, okay, the current is given in ampere. That's it's a very important thing actually. So it's actually very important thing. The unit is very important. You have to consider the unit in every case. Okay, it's given by in ampere. So there is nothing to worry, because the unit of current is ampere. The standard unit of current is actually ampere, and it is also ampere. If it is milliampere, so then you have to convert into ampere. How will you convert a milli terms into a full digit? By multiplying with the 10 raised to minus 3. If it is a microampere, you have to multiply with the 10 raised to minus 6. Okay. So it's actually very basic concepts. Okay. So you have to consider the units at an instant time of t, and also here the t time is given in seconds. So there is nothing to worry actually. Is given by I is equal to. So we can write the equation. I is equal to 4 minus 0.08 t. Okay, 0.08 t. The number of electrons flowing in 50 seconds. Actually, the time is given by time is equal to 50 seconds. The time is actually given by 50 seconds. Through the cross-sectional area of the conductor is actually the question is you have to find the number of electrons. That's the question. Okay, how will you connect these terms? The equation is from like that. I Tn. How can I connect these terms? I have no idea how to connect current, time, and number of charges. That's actually not practically possible. So use your common sense. We know that charge is equal to n into e. Charge is equal to n into e. So then, if you want, you can connect I, T, and Q, and find an equation for Q. So just find an equation for Q, then replace the term with Ne. Q is equal to Ne. You all know that the Q is the charge, which is an integral multiple of base charge. It is one of the properties of electric charge from the first chapter. So if you don't know that topic, so just go through the topics, you will get a clear idea. So I is equal to Q by T. So what is the relations between I is equal to Q by T? So the relation is exactly the same. I is equal to dQ by dt. So we have to find a Q. So the equation will be changed something like Q is equal to integral I dt. It's exactly the same process. So I am stepping the basics mathematical steps here. So I is equal to integral I dt. So just integrate the terms. Q is equal to integral 4 dt. The first term is 4. You have to integrate the first term. So separating the integration, that's okay. It's integrating the first term and integrating the second term. What is integrating the second term? Minus, okay, fine. Integral 0.08 t dt. 0.08 t dt. That's the thing. So while we are integrating, we will be get something like this. Q is equal to 40. The first result will be integrating 40 minus 0.08 will be step back, and integral t will be something like that, t square by 2. This will be the integration. This will be the result of integration. Q is equal to 40 minus 0.08 t square by 2. So we are find the value of charge actually. Q is equal to, with an equation, 40 minus 0.08 t square by 2. But the actual question is, you have to find the number of charges, right? Yes, you have to find the number of charges. Okay, then there is one more catch. Here we go. Within the time, you have to consider the time within the time 50 seconds. Okay, so here we want to apply the time limit, and we have to apply the equation Q is equal to NE. If we are applying the both in a single step, we will be end up plus something like this. Okay, fine. Or we can just take one more step. That will be okay, fine. That's not a problem. So we can Q is equal to, what is the equation we obtain now? Q is equal to 4t minus 0.08 into t square by 2. I think it's correct. Yes, right? Yes, Q is equal to 40 minus 0.08 into t square by 2. So in that situation, we have to put the value t is equal to 50. T is equal to 50. Okay, then Q is equal to 4 into 50 minus 0.08 into 50 square by 2. Simplifying these terms are actually the basic mathematical skill that you have to develop. Yeah, you are studying in the 12th standard, you have to develop. Okay, so it's actually it's not a matter of discussion. Actually, you should know how to simplify these terms. Okay, Q is equal to 4 into 5, actually it is a 200 minus, I would like to simplify. You can done it in a simple way, so I'm just explaining it. Okay, 0.08 can be considered as 8 by 100. If you want, you can consider as 8 by 100, because there are two terms, 8 and 0 after the decimal point. So we can simply convert it to 8 into 100 into 50 square something. We can replace something into 50 into 50 divided by 2. So when I am cutting these two values, 0 and 0 will be cancel each other, 0 and 0 will be cancel each other. These terms will be cancel each other, and 2 and 8 will be cancel each other. That will be 4. 5 into 4 will be result into 25. 25 multiplied with 4 will gives you the answer of 100, and Q is equal to 200 minus 100. It's a very basic thing. Okay, I'm sure that you will know these steps. Okay, it's actually very basic thing. Okay, Q is equal to, when 200 minus 100 will be give to a reading of 100. Okay, so we end up with the value for the charge, but actually the question is, you have to find the number of charge. How will you find the number of charge? By replacing the equation, NE is equal to 100. N is equal to 100. So how will you find N? N is equal to 100 divided by E. 100 divided by E. So that's the catch. Here we go. You have to know the charge, basic charge, and it's something like 1.62. There is a reading. I am just shortening it to 1.6 into 10 raised to minus 90. The reading is something like E is equal to 1.6 into 10 raised to minus 90. When I'm looking at the equation here, it is actually 10 raised to minus 90. And I'm coming to the given mathematical expression, N is equal to 100 by E. So it's just a common sense. I'm replacing the 100 as 10 square. So that will be more easy to do the mathematical operations. Okay, so many of the students ask me the question, how will you know you have to convert 100 into 10 square? It's just a common sense. How will you get the common sense? By doing the problems. That's the only way. Okay, I cannot teach you, I cannot give you any mantra to learn these things. There is nothing like that. You have to do the problems again and again and again. Okay, so then you will be know with the then it will become a muscle memory. Okay, you know the term known as muscle memory. Okay, okay, we are doing something which we are not able to think. We react first. That's the thing. Exactly. When we are doing so much of problems, you will be normally you will be reacting to the question. Okay, so there will be nothing to worry about that. Only one thing is, you have to create this muscle memory. How can we create something, a muscle memory? To do the questions repeating. Okay, so actually N is equal to 100 by E. So 10 square divided by E is equal to 1.6 into 10 raised to minus 90. Taking the denominator to the upper value, it will become 1 by 1.6 into 10 raised to, the answer is 2. Minus 90 will become plus. So 90 plus 2, so the answer will be 1 by 1.6 into 10 raised to 21. Okay, so you have to know an approximate reading, not the exact value. You just need an approximate reading. What is 1 by 1.6? If I multiply with 1.56 into 5, that will be 5.68. So it's, the reading will be, if I multiply 1.6 with the 5, okay, you have to multiply 16 with the 5. That's enough. Okay, so you have to end up with a term, something related to 8 term. So that is not actually okay. You have to reach the term 10. Okay, so you have to multiply with the 6. Okay, 6 something reading. So the value will be 6 point something. Okay, 6 point something into 10 raised to 21. Okay, that's accuracy you need. Okay, so you have the options here. So you do not need 100% accuracy. You just have a 90% accuracy. That's enough. Okay, so you when you go to the options, you can find that. Okay, even though, okay, you can find that the value will be something like 6.25. The option is here. It is the 10B. Actually, it is the option here, 6.25 into 10 raised to 20. So that's it. Okay, so we are moving to the next topic known as drift velocity. It's one of the important topic. So what is a drift velocity? It is the average velocity. It is average velocity acquired by an electron in the presence of an electric field, or it's the presence of an external electric field. Okay, let me conclude that. Okay, just take a, we are going to take a conductor. Okay, in this case, we are going to consider a conductor. A conductor will always have large number of free electrons. Okay, so that's it. Okay, this is a conductor. This conductor contains large number of free electrons. What is the thing about free electrons? It will be random motion. It will be always in random motion. So these electrons are in random motion. Okay, fine. That's it. Okay, this conductor we are going to place. Okay, this conductor is going to place in an external electric field. What if it is placed in an external electric field? Okay, so we are placed it in an external electric field. These positives and negatives, these are the external electric field that we are placed over here. So what will happen? These electrons will move in a steady way. Okay, these electrons will be directed towards, because the charge of an electron is always negative, and this will be directed towards the positive charge. So that's it. Okay, when an conductor is present in an external electric field, it will be moving in a steady way. If external electric field is not present, it will be in a random motion. Okay, so that's it. What is the direction of electric field? Okay, as you can know, the direction of electric field is always from positive to negative. Okay, this is actually a very basic topic that we are discussing in this chapters, first chapter and second chapter. The electric field, direction of electric field is always from positive to negative. Okay, while the electrons or the base charge here is moving from negative to positive. What does that mean? It means that both of them are in the opposite direction. Electric field and the electron or the base charge. It's actually the base charge. So electric field and base charge are moving in the exact opposite way. Okay, so what is the expression for drift velocity? It's actually minus E capital E tau divided by M. Minus E tau divided by M. We have to explain each and every terms. Okay, here we go. So we are going to explain each and every term. Okay, so that's it. So what is the equation for drift velocity? The equation for drift velocity is actually, sorry for that. Okay, the equation for drift velocity. The equation for drift velocity is actually V is equal to minus E, capital E tau divided by M. Okay, you have to express each and every term. Okay, what is the term negative indicates? The negative indicates that electron or the base charge. It's actually the base charge, not the electron. Okay. Anyway, the base charge and electric field are in the opposite direction. Electric field and electrons are in the opposite direction. What is small letter E means? It means actually the base charge. It is the base charge. What is capital E? Capital E means the external electric field. Okay, you have to remember that it's actually electric field. It's actually external electric field. What is tau? Tau is the relaxation time. Tau is the relaxation time, and M is the mass. So that's it. Okay, so here we have with the relaxation time. Okay, and and there is also one more equation that's very important. The equation which connects drift velocity and current. The equation which connects drift velocity and current is actually I is equal to NAVE. I is equal to I is equal to NaVe. And you have to know each and every term. N is the electron density, number of electrons in a unit volume. Number of electrons in a unit volume. And there is an A, area term, and V is the velocity term, and E is again the base charge. So these are the equations for drift velocity and the concept for the drift velocity. There are a few questions we have to discuss in this topic, okay? And there is another term called mobility. What is meant by mobility? The amount of movement. Right, yes, exactly. What is mobility? Mobility mean by a simple term known as the amount of movement. Okay, how will you move? Okay, that's mobility. So mobility is the ratio of drift velocity with respect to electric field. Okay, how am I end up with the equation something like this? Okay, here we go. Mobility means the movement. Movement is the velocity. If a body have high velocity, the mobility is high. If a body has a low velocity, the mobility is low. Just consider these two cases. I'm placing a square-shaped object, and I'm placing a square-shaped object and a two kind of objects. I'm placing on an inclined plane. What will happen? Okay, this spherical-shaped body will attain large velocity, high value of velocity. This body will attain a small value of velocity. We can say that the mobility in these two cases, mobility is higher in the B case. Right, yes, the mobility is higher in the B case. How we end up with that conclusion? Because that the velocity is high in the second case. So mobility is a term which is closely related to velocity. If a body have a high velocity, it is closely like to have a larger mobility. So the equation for mobility should consider the term velocity. So it is considered velocity. Okay. So why electric field? Why external field? Because the external field is the reason for this mobility. You have to consider that also. There is a mobility, fine, that's okay. But there is a reason for the mobility. The reason for the mobility is actually this external field. So mobility is equal to Vd divided by E. That's the equation. Here we go. So the equation for mobility, we can reduce this complicated equation into something like this. E tau divided by M. So that's it. Okay. Fine, clear. So we can go to the questions actually here. So we are going to the question discussion section. When the current I, so it is given by, the current is I, okay, clear. The current is given by I, okay, that's it. Flowing through a conductor, the drift velocity is V, okay. When a current I is flowing, when a current I is flowing, the drift velocity is actually V. The drift velocity is actually V. Okay. If a 2I current is flowing through the conductor, so the current is changed into 2I. This current is actually changed into 2I. Then the area of cross section is actually with the same metal having double the area of cross section. So the area is actually changed into 2A. So what will be the value for the drift velocity? In the first case, when the current is I, the drift velocity will be, okay. You have to connect these two terms. Which are the two terms? Okay. So I am considering these two equations. I am writing from the first case. So just read the question. There are two terms, current and drift velocity. How will you connect these two terms, current and drift velocity? We'll end up with the equation I is equal to NaV. Here we go. Relation connecting drift velocity and current. So I'm going to connect these two equations first. Okay, I'm going to connect these two equations first. Current and drift velocity, I is equal to, this is the equation for current and drift velocity. That's it, okay. So the question is, what about the drift velocity? In the first case, drift velocity is V is equal to I divided by NEA. This is the first case. Current is actually I. Yes, clearly the current is I. The current is actually I, the area is A. In the second case, I am changing the velocity. Okay, how I am changing the velocity? I am changing the velocity by changing the current into I into 2I. That's the first point. And area A into 2A. So putting these two values, we will be end up with an answer something like this. I is replaced by the term 2I. NEA, A is replaced by the term 2A. So the common terms, which are the common terms? The 2 and 2 will easily cancel each other. So the final equation will something like this. V dash is equal to I divided by NEA. just observe closely. Just observe closely. Give it a try. Give it a shot. You understand that both of these values are exactly the same. Both of these values are exactly the same. The new drift velocity and the old drift velocity are exactly the same. So what is the correct option? Which one is the correct option? The correct option is actually the C. Is that clear? Okay. Let me know in the comment section. Let me know in the comment section. If you have any kind of doubt or any kind of problem, just comment me. I will clear that. Or you need to know the concept of any topics, 11th, plus 2, even entrance, any kind of topic. You just ask the question in the comment section. I will give you a clear video on that, a clear lecture on that topic. Okay, clear. To the next topic. The drift velocity of electrons in a copper wire of length 2 meter. Okay, the drift velocity. You have to understand. Okay. You have to understand. You have to know how to read a question. That is the first part. Okay, answering is not the important part. You have to know. You have to understand how to read a question. And again, it's a muscle memory. It's a clear muscle memory. So only you can attain this memory by doing repeated amount of questions. Only by doing repeated amount of questions. So here we go. Here going with the drift velocity of the electrons in a copper wire. Okay, the drift velocity of electrons in a copper wire. So the first term is actually the drift velocity. So I am understanding the term, the technical term here, the drift velocity. So that's it. Of the electrons in a copper wire of length. The length is actually given by 2 meter. Okay. Under application of potential, that's a new term actually. That's a new term. So potential is 200 volt. So that's it. The velocity is mathematically given. Their mobility in, what will be the value of their mobility? That's a good question. Okay, so we can go something like this. Mobility, we know the basic equation for the mobility. Mobility is equal to drift velocity by electric field. Mobility is the ratio of drift velocity with respect to the electric field. Okay, so that's it. So you have to know the drift velocity and the electric field, right? The drift velocity is already given that the drift velocity is actually 0.5 meter per second. It's actually given. Okay, so you have to know a drift velocity, and it is already given. Then you have to know the electric field. What is the value of electric field? You have no idea about the value of electric field. We have absolutely no idea about the value of electric field. But there are some terms known as potential and length. Okay, so in the second chapter, there is a concept, there is an equation which says something like this. You can connect these two terms. Which two terms? Potential and electric field. The value of potential is actually the multiplication of electric field with the length. Electric field length. With the length. I can give you a small lecture about this topic actually. Here we go. Okay, so I'm dealing with you in every question. I'm dealing with the exact concept. So what is the value of electric field? I'm going to the first question. What is the value of electric field? The value of electric field due to a point charge is 1 by 4 pi epsilon 0 q by r square. It's a very simple thing, we know that. Okay, fine. What is the value of potential? I'm writing this term in over here. Actually, I'm writing this term over here. What is the value of potential? The value of potential for a point charge is 1 by 4 pi epsilon 0 q by r. Value of potential is v is equal to 1 by 4 pi epsilon 0 q by r. So what if I am multiplying this equation with the r on the both side? Okay, I am simply multiplying the equation with the r on the both side. What is mean by r? R mean by the distance or the length. Okay, we will end up with the left side of the equation will be changes into E into R. What will be the change in the right side? The R square and R will be cancel each other. The R square and R will cancel each other, and we will find an equation 1 by 4 pi epsilon 0 q by R. Okay, what a magic. 1 by 4 pi epsilon 0 q by R. What is this term? We are familiar with this term actually. it is the potential. It is the potential. So we know that if you multiplied electric field with a distance, you will end up with a potential. That's the concept. Okay, that's the concept. So if you want to find the electric field, you have to find the electric field. You can simply divide the potential with the length. Here the length is R. In the question, it will be something like 2, 3 or any kind of value. So I'm just writing a generalized form. E is equal to V by length. Is that okay? Clear? Right. Okay, so we can go to the question. So what is basically potential? I'm going to another topic actually, concept here. What is basically potential? Anyone? Anyone can tell that. What is actually a potential? This thing, many of the students have the definition. Okay, you will have a definition like it is the amount of work to bring a body from infinity to blah 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 blah. Okay, etc etc etc. That's not the actual point. What is mean by potential? What is purely mean by potential? You know the topic. You know all the chapters. What is mean by? Okay, just simply explain the term potential to a 8th standard student. How will you explain the term potential to a 8th standard student? How will you explain? So if you cannot explain that thing to an 8th standard student, it means by that you don't understand the topic at all. You don't know the concept. You're all just by hurting the equations or by hurting the sentence. That's not okay. Actually, potential means repulsion. Write down it. It's very, very, very important. You all know that the charge flows from high potential to low potential. What does it actually mean by high potential to low potential? Just consider these two equations. Okay, I am taking a place with the 100 electrons. Here are 100 electrons. The charge of an electron is negative. So the negative and negative will be repelling each other. Yeah, right. Okay. So there is another place where I am placing a 2 electrons, only just a 2 electrons. What will happen? If I connect this with a conductor, what will happen? What will be happen? Just a basic common sense. The charge will flow from here to here. Why the charge is flowed? Because here it is very much repulsion, very much of repulsion. Here the repulsion is very value is very low. So clearly the charges flow from high repulsion to low repulsion. That's it. High repulsion to low repulsion. That's it. That's the point. Okay, fine. So potential means the repulsion. Understand the thing. Okay. So here we go. Here we want to find the E. So I'm going to find the E. E is equal to potential by length. Okay. In this question, I think the potential is 200 volt. 200 and the length is given by 2 meter. So the electric field will be 100. So that's it. Okay. So applying these equations to this point, mobility is equal to the drift velocity is 0.5 divided by 100. Okay. So that's it. So okay. You have to make the answer which the answer should be the answer should be in the options. Okay. So sometimes we will get the right answer, but the answer will not be in the options. So you have to convert your answer accordingly to the options. Okay, so that's the point. That's another kind of art you have to know about that. 5 divided by 10 square. So it's actually given. The value is actually here. So you have to go something like this. You can take 0.5 divided by 10 square. The term come to the upper part will be 0.5 into 10 raised to minus 2. Okay, so go to the options. Is there any term something like 0.5 into 10 raised to minus 2? Actually, there is no term 0.5 into 10 raised to minus 2. But actually, there is a term 5 into 10 raised to minus 3. Okay, if I am changing this decimal place, I will end up with the 5 into 10 raised to minus 3. So the option is actually the D. D is the correct option. Okay, that's it. So you have to convert your correct answer into the options. That's also an important part. Okay, clear? So we have to go to the next question. What is Ohm's law? Okay, so what is Ohm's law? I already given an explanation about potential, so it will be much easier to discuss. Ohm's law. It's very important. The most important point is okay. Everyone know the Ohm's law. Something like potential is directly proportional to I. Okay, so the most important part is actually not V directly proportional to I. The most important part in this equation or this topic is actually at a constant temperature. Understand this point. Okay, at the constant temperature, you can apply Ohm's law only when the temperature is a constant. Okay, you have to keep in that mind. Write down the point that the temperature should be a constant. The current flowing through a conductor is directly proportional to the potential difference. Okay, already we have discussed that the current is the flow of charge. The flow of charge is based on the repulsion. If the repulsion is high value, the flow of charge will be high. That's it. If the repulsion is very small, the flow will be small. Okay, the flow will be a low value. That's it. Potential is directly proportional to I. if we want to make this proportionality to an equation, you have to put some constant. Here the constant is r, so v is equal to ir. So know this point, understand this point, that r is actually a constant. Yes, that's the point. R should be a constant. The resistance should be a constant. The resistance will be constant only if the temperature is constant. So that's it. So what is basically a resistance? It is the ability of a conductor to oppose electric current. So that's it. Okay, so we can go through the question sections. Okay, I think it's okay. It's all right. Clear. So just let me know in the comment section if there is anything I have to explain. Please let me know in the comment section. Okay. To the problem, the resistance of a wire is 20 ohm. It's given that the resistance of a wire is actually 20 ohm. Okay, here we go. The resistance of a wire is actually 20 ohm. So that's it. Okay. And it is stretched. Here we go. There is a term like stretched, that the length becomes 3 times. Okay, so just imagine if L was the original length. The new length is 3 times of the original length. Okay. In this kind of questions, you can see several questions which is related to stretching. Okay. Then the question is here. Then the new resistance will be. Then we have to find out the new resistance. Then you have to find out the new resistance. So okay, fine. You have to understand that there is a small equation for stretching. It says that if a body is stretched, okay, to the equation, if a body is stretched, okay, so if a body is stretched, R is directly proportional to, okay, the R is directly proportional to square of the stretching. It is directly proportional to square of the stretching. The new resistance is directly proportional to square of the stretching, okay. In this particular case, the stretching is actually 3 times, okay. The amount of it stretched is actually 3 times, okay. The L dash is actually 3 times, which says that the new resistance should be, okay, replacing the term, we will be obtained with this value. The new resistance will be 9 into, okay, 3 square, it will be 9. The new resistance will be 9 times of original resistance. That means the new resistance is 9 into 20. So the value will be 180. Okay, it's actually a very simple equation which says the new resistance is directly proportional to the amount it stretched. The amount it stretched is actually here. 3 times. Okay, so we are placing the 3 value, which implies that the new resistance will be directly proportional to 9 times of the original resistance. So that's it. R dash is equal to 9 into 20. So the new value will be 180 ohm. So that's it. Okay. So it's actually a very simple equation. Okay. We can go through. The new resistance will be the square of the times of how many times it is stretched. Okay, so that's it. We can go to the next section, next question. The resistance, exactly the same kind of question. The resistance of a wire is 10 ohm. Okay, here we go. The resistance of a wire is 10 ohm. So I am going to write this equation. Resistance is actually the original resistance. Here we go. The original resistance R is equal to 10 ohm. The original resistance R is equal to 10 ohm. That's it. Its length is increased by 10%. Its length is actually increased by 10%. By stretching, it's already stretching, the new resistance will be, okay, so what will be happen? It is actually 10%, the initial resistance is 10 ohm. We are stretching, okay, so we know that R dash is directly proportional to L dash square. If we stretch into 10%, what will be the error? Okay, actually this topic is from the first chapter in the 11th section, units and measurement. It is known that there is an error, there is a change increased in the length. Length is changed by 10, which implies that the error will be 2 times. So R dash should be 20%. R dash will be 20%. So the new resistance will be sum of old resistance plus 20% of additional resistance. So R dash is equal to the old resistance. What is the value of old resistance? The value of old resistance is actually 10 ohm plus 20% of 10 ohm will be something like 20 into 20%. You have to convert it percentage into value. 20 by 200 into R. The original is 10. Okay, we can cut these terms. The final result will be 10 ohm plus 12. So the final value will be 12 ohm. The final value will be 12 ohm. So that's it. Okay. So we can go to the next question. The next question is actually the reciprocal of resistance. So what is the reciprocal of resistance? The reciprocal of resistance is known as conductance. And what is the reciprocal of resistivity? The reciprocal of resistivity is known as conductivity. Okay. So we are winding up this session. We are going to a conclusion. Okay. There is actually a part 2 for this video. The current electricity is not completed yet. The main topics are actually in the next part video. We have discussed the resistance, Ohm's law, and the basics of current in this session. So we can come with a new part and it will be uploaded. Okay, we will be in a live within a few days. Okay, see you soon.